Hello and good morning, everyone. We will begin momentarily, so just wait for another 3-4 minutes and we will get started with today's webinar. Thank you. Morning, everyone. For those of you joining us, we will begin in 2 minutes. All right, let's begin today's session. So thank you for everyone who's joining us today for another one of our monthly technical webinars. Today, I'm excited to facilitate this webinar along with Siemens on how to improve the DeltaT and save energy using intelligent valves. So just a bit of housekeeping before we begin. So if you're joining us for the first time, my name is Jason John, and I'm the technical engineer here at the Emirates Green Building Council. The Emirates Green Building Council was formed in 2006 with the goal of advancing green building principles for protecting the environment. Our vision is for the UAE to be a global leader in sustainability, and our mission is to act as a catalyst for collaboration and a hub for excellence to promote sustainability. So if you're using this platform for the first time, the GoToWebinar platform, uh, all of our attendees who are joining in, you are muted automatically and your webcams are turned off. They will remain turned off and you won't have microphone access throughout the duration of this webinar. But if you have any questions that might arise during the presentation or even after the presentation, I would highly recommend you to use the questions feature on your right hand side on the control panel. So if you have any questions that you wish to ask, please put them down. We have two great experts here facilitating today's webinar, and they will happily take any sort of questions that you may have during the end of their presentation. Our team will be monitoring the questions as they come in, so please make sure you get those questions in as soon as they come up. For if you need the recording of the presentation, so we will be sending out the recording of the presentation just after the webinar ends, so please do keep a lookout for that. Once you exit the webinar, I kindly ask you to just complete the survey that basically informs us for any sort of future topics that we would like to address for our future webinars. And lastly, follow us at EmiratesGBC on our social media to be up to date with our upcoming events. So with that, I am going to be passing over the presentation to our first facilitators for today. So let me introduce them to you. So we have today joining us Jörg Hill, the Global Product Manager for Valves and Actuators. He is based at Siemens Building Technologies headquarters in Zug, Switzerland, and responsible for electronic dynamic balancing solution. He holds a Master of Science in Mechanical Engineering and started his career in 1994 as a regional product manager for district heating, controls, and valves and actuators in Germany. As the global product manager for several product lines over the last 2 decades, he has shaped Siemens valve and actuator portfolio. Today, he focuses on new intelligent solutions for dynamic hydronic balancing and energy saving within hydronic networks. Our second facilitator for today is Luca Baroli, also the Global Product Manager for Valves and Actuators. He is also based off of the Siemens Building Technologies headquarters in Switzerland, and he is responsible for electronic dynamic balancing solution. He has enhanced professional experience by supporting his customers during installation and commissioning of many prestigious projects, not only in the Middle East and the UK, areas of main focus for his role, but all across the world, gaining a comprehensive knowledge of flow control related matters. So thank you for joining us, Mr. Baroli, Mr. Hale. I will now hand over the presentation control to you, and we can get started. So Luca, I am making you the presenter first.
Very good.
Fantastic.
So, turning my camera on. I hope you can see me well. Good morning, everyone.
Yes, perfectly.
I'm going into presentation mode, and then we can start. All right, I guess we're good to go. So once again, welcome. My name is Luca Baroli, and as the colleague said, I work for the Global Product Management Department of Valves and Actuator at Siemens Smart Infrastructure. Target of today's presentation is to look at how to improve the efficiency of hydronic distribution systems in buildings with intelligent valves. However, before we get there, I hand over to my colleague Jörg. For that part, I would like to give you an overview of where the technology in this industry stands with respect to dynamic balancing solutions. In fact, nowadays, the energy efficiency potential in all sorts of industries, vertical markets, and infrastructure is still capped. If you look at buildings, according to different institutes, the energy efficiency potential is still pretty much unrealized. And we could estimate that only 20% across the buildings worldwide has today reached an adequate level of energy efficiency. In addition to this, it must also be said that the world is changing the market, and the industry itself is undergoing a deep transformation. And this means that even the buildings where people work are changing as well. In fact, if you look at a typical building that was built a few decades ago, it was always dedicated to pretty much for the same purpose. For example, office blocks, always occupied during working days, and then free over the weekends. But today, with flexible rental options, faster market dynamics of many new businesses, and even the increased rate of remote working due to the spread of the pandemic situation, the usage of the buildings becomes much more flexible. Even more, it's already happening now, but especially in the future, connectivity to the cloud, to external networks, to the internet will be definitely the game changer for the overall efficiency of buildings and infrastructures. If you look back at the history of the energy efficiency with regards to valves and actuators, there is a long path which is finally arriving to what we call today the intelligent valves. And the interesting part of this path comes when dynamic balancing technologies was brought into the market, which we could consider somewhere along the line between mechanical, automatic balancing valves and PICVs. And thanks to these technologies, companies are nowadays able to offer solutions which are all pretty much based on dynamic balancing. We believe that PICV technology is becoming the standard that should be used in every environment and section of the building or infrastructure's distribution water system. Obviously, on thermal units, but also in the distribution and generation part. Let's take, for example, the case of a renovation of a building which requires an extension of the hydronic network. Say you want to replace all core units, but it could also have been, a renovation. The same applies. If you want to readapt the hydronic system to the new configuration, if you are looking for using the old technology like static balancing, then you need to recommission the complete system. If you have done it, you know what I'm talking about. Even the parts that are not involved in the changing, and this is something that you definitely don't want to do anymore today. And this, as we know, for a static valve solution means a lot of redesign work as well as on-site readjusting and commissioning. The formulas on the screen are not meant for you to be read, just meant for you to make you aware of the complexity of the redesign work. A lot of time, money, and resources must be employed for this purpose. But if you want to optimize the efficiency of this process, then you can opt for PICV. But what is a PICV and why the benefits are not only related to commissioning, water balancing aspect of the whole project? Let's see, it's just a recap. PICV is typically 3 devices in one. It's a control valve with an actuator on it. It has a manual flow presetting, and the dynamic balancing is granted thanks to a mechanical differential pressure regulator built in the valve. But today, as we said, we are not looking at PICV technology. We'd like to have a look at the energy performance of a dynamic balancing distribution system with mechanical PICV and how this can be improved by the use of intelligent valves. So let's consider a cooling application. Here I have proposed a very simple schematic for better understanding. The chiller sends cold water to the coil of the air handling unit, and the incoming air in the duct is cooled accordingly. So after transmitting its thermal energy, the water returns slightly warmer, right? The system in this case is designed to operate at full load with 6 degrees flow temperature and 12 degrees return. So we have a difference of 6 degrees, and this is what we call DeltaT. This difference is very important because a chiller works most efficiently when this gap is the largest. So what you want to do is to keep the DeltaT at the highest possible level. So what happens when you control this loop with a static control valve? Well, obviously, you're not going to have just one coil in your hydronic distribution system. You are going to have many coils. The system will be more complicated, and there are many factors that influence the energy demand, and therefore the return temperature. For example, at the beginning of a meeting with a large audience in a conference room, you need extra capacity. Or at the beginning of the week, when you switch from reduced comfort to normal mode, you need extra capacity. And when the chiller pumps more energy in the system, if you have a standard valve which has no capability of compensating pressure fluctuations, then you likely end up having overflow during these moments in some places, but because the flow is distributed unevenly, the energy is not properly transmitted when you need it. So you're going to have excess overall energy, but somewhere the energy is lacking because there is too much of it somewhere else. This is what typically happens with static balancing. And in this case, the return temperature is lower because there's no proper exchange of heat. And the delta T then gets lower. For instance, if the delta T gets reduced down by 2 degrees, the chiller loses efficiency by a significant amount. And the exact amount of lost efficiency depends on the chiller and on the specific duty point of the system. And a first and very good mitigation measure is to use PICVs, because thanks to the dynamic balancing compensation, the flow in the terminal unit is always limited to 100%. Therefore, the energy transfer is more efficient with a delta T of, say, maybe 5%. The pump is not using as much electricity and the chiller works quite efficiently already. Nevertheless, let me also mention that a PICV alone can never guarantee that your delta T is going to be always the highest, simply because a PICV can only control the flow and has no direct influence on the temperature. So for this, we see later, you need intelligent valves. But this improvement, moving from static to dynamic balancing, saves already up to 30% energy and preserve comfort. As a support of this statement, of this 30%, there are several studies available in literature, and I would suggest to have a look at these 2 documents, which explains how and why such a saving could be achieved. So the Siemens white paper on the left deal with energy savings in a real case for the Middle Eastern region. Please get in touch with us if you want to get it. Before handing over to my colleague and see what the intelligent valve can do to improve even further the delta T, let me just complete my part by mentioning what you will see in the independent energy report of Visrea on the right side, and how, if you look at the electrical consumption of the secondary pump, you can save even much more than 30%. So this is basically the summary that you would find in that report. And if you look at just the red and the blue piping layout up here, we can now compare the energy performance of the 2 different valve sets shown here. The first one at the top is a static control valve with a manual balancing valve. And there is, you don't see it, but there is also consider a differential pressure controller for the risers. And the second one is basically a PICV arrangement. So without manual balancing valve and without any other regulating valves along the main lines. And very interesting is that you can check to what extent the energy saving can get if you mix the right combination of valves with the correct pump control strategy. What is the pump control strategy? Well, as you probably know, variable speed pumps can be controlled in at least 3 different main or most known ways. There is constant pressure control, you see here, proportional variable pressure, you see the black dotted curve, which is basically the characteristic of the pump along the flow and the head of the pump itself, the pressure. And also interesting that you can control the pump by means of a remote sensor. We could speak maybe for hours about this, but to be short, to make it short, imagine a system like this one, and then you install a differential pressure sensor somewhere nearby the least favorite circuit, and this sensor communicates back with the pump. So this method could be called remote sensor speed control, where the pump is driven according to the signal of a sensor which monitors the trend of the delta P in a specific point of the system, called the index circuit. Or in reality, people place these sensors somewhere close to it. So once we understand what is done, we can now check what happens to the energy consumption of the pump if you use traditional valves or PICV with the various pump speed control strategy. In the first case, with the constant pressure control, we can see the saving goes close to 25% when you switch from a static control to PICV. But if you look at the remote sensor speed control strategy, then the saving, it goes even beyond and reach a relevant amount of 50%. So and this is obviously the reduction of the secondary energy consumption of the pump. Amazing, right? So there is absolutely no question that PICV provide very great benefits to the hydronic distribution system energy balance. But some of you may ask, is it worth the cost, moving from a more complex valve, paying more upfront cost? Is it really worth? And for the many of you that are familiar with PICV design, it is obvious to see that there is no longer need for a manual balancing valve in the system, because PICV is 3 valves in one. Therefore, you can eliminate any other control or balancing element. But not only, in fact, it is clearly much easier to balance a new or refurbished system, as there is no painful iteration along the coils of the whole building. So even the setup, it's much easier, quicker. So summarizing, considering a use case of a building, for example, with 500 rooms, it could be a hotel, and the standard cost of the control devices, as well as hourly labor cost, the savings can reach and overcome, we calculated more than 25%, 28, like in this example. This is amazing, but this is just the beginning of the journey, because now I am going to hand over the microphone to my colleague, Jörg Heil, who will continue to deep dive into these dynamic balancing energy saving opportunities. And from my side, thank you very much for your attention, and see you later for the Q&A sessions. Control, back to you.
Fantastic, thank you, Luca. So Jörg, I'm just going to make you the presenter now. And you should have access to the presenting.
Yes, good morning. A warm welcome from my side as well. My name is Jörg Heil, and I'm a product manager as Luca here in Switzerland at the Smart Infrastructure headquarters. Today, I like to share some thoughts about intelligent valve solutions for dynamic hydronic balancing, and also especially for dynamic power balancing and temperature management, which these solutions offer. I hope, yeah. So this we have seen from Luca, a nice wide hydraulic network with a lot of consumers. With the PICVs, thanks to the PICVs, we have now the flow under control. We can avoid starving coils, we can avoid excessive overflows to consumers, and also we have optimized the needed energy for the pump. But have we really done everything to guarantee energy efficiency in this system? And have we done everything to guarantee a good and optimized power distribution to each and any consumer? Can we at least guarantee that each riser gets the right power? Can we optimize the operational costs on these? And what would we need for this? We would need more information from the system. We would need local temperatures of flow and return to the risers and to the consumers. We would need power measurement to the risers so that we can react on the power consumption of each and any of these risers. And we need it online to react on this, online on the BMS system, to have it under control and also to supervise the system. So a PICV could not do this from the today's perspective. Let's have a look on a solution we see which can do such things. And now we are switching over to intelligent valve solutions. Intelligent valve solutions are also at least pressure independent control valves. They are usually as different to the mechanical PICVs. They contain, for the flow control part, they contain a precise flow meter as a base for the balancing. They have a pair of temperature sensors locally connected here, and they need a high resolution valve and actuator combination for a precise flow control. And that's the most important element in all these intelligent solutions, they have a local controller. This is this controller box here, which can on the one hand side take care for the local optimization functions. Here we can limit the DeltaT, we can control the power, measure the power and control the power, and also limit power if needed. And also this control box is there to provide all this local informations into the building automation network, to the building automation controllers. So there we can deal with this informations to optimize the comfort control loop, and also integrate it into the building management system. We can do the supervising, we can do a trending for later optimizations. We see alarms, and we can do energy reporting. And also, if an BMS is not available, this may allow us, an IP connection may allow us to connect into a cloud solution. So this will save costs due to less installation effort and less system installation effort, and have the trending and reporting in a cloud solution. In addition, also with this intelligent and electronic solution, we have the capability to connect to this local device by a mobile app, as today's standard of the technical standard. And there, for the local technicians, we have the capability to do online clear text alarming, and to have also a guided structured menus for troubleshooting, so that we have a guided troubleshooting. Comparing to traditional PICVs, there are some differences between an intelligent solution and a PICV solution. Here we see a PICV is a fast-acting device, purely mechanical, needs a local presetting usually on the device. On the other hand, an intelligent solution, the acting is based on the flow measurement and on the actuator reaction time. So it's a moderate reaction in regards of DeltaP performance, but you have the additional capability to do presetting remotely if integrated into the network, and all the additional functionalities, real-time flow measurements, real-time temperature measurements. You can do a power limitation, a DeltaT limitation. You can then run local optimization functions on this device. And all these values are integrated into the network. And so you have it on the automation level as well as on the BMS. Now you might say an intelligent solution like this with a flow meter and the temperature sensors, this might be a little bit too expensive for each and any consumers. But think about a solution like here, you have the network with the consumers, and to get to an affordable investment level, you can do PICVs on the consumers and intelligent valve solutions on the risers to have the power distribution under control here, and also especially to have the DeltaT under control. The PICVs take care about comfort in the rooms and zones, and the intelligent valve solutions take care about efficient operation of the complete network. Now let's focus on the optimization functions of such intelligent valve solutions a bit more in detail. Why is DeltaT important? Just because with the DeltaT is influencing, and especially the return temperature is influencing the efficiency of the chiller. With each Kelvin return temperature you can increase, you will at least gain 3–4% of chiller efficiency. And at the same time, when you increase the DeltaT, clearly you will reduce pumping cost because you reduce flow by a couple of %. So it's just more efficient, energy efficient, to pump around 500 cubic meters with 6 Kelvin DeltaT instead of pumping around 1000 cubic meters with 3 degrees DeltaT. So the net power consumption of the generation and also of the network will drop clearly with increased DeltaT. Now, how does this work actually? Here we have the example from Luca with the PICVs. This is a very good first step. We keep the flow, the maximum flow under control to the design flow. And with that, we have already increased DeltaT to a certain level and saved some energy there. We can see this also if we look on the transition curve of the coil. This might be the transition curve of the coil in this air handling unit from 0 to 100%. So here we go with a coil for 600 kilowatt roundabout at 100 cubic meter. Now, this is the DeltaT across this coil with the flow. So at low flows, at part loads, it's quite high. It's here on the right-hand side, 10 degrees at 40 cubic meters, which is a good value, 10 degrees DeltaT. But what's about full load conditions? Here, with a standard valve, no flow limitation, flow will go up as far as it can. Let's assume 135 cubic meters. We will end up in a quite low DeltaT, around about 4K. With the PICV, we have this flow limitation to the design flow. We have the 600 kilowatt power available on this coil with the 5 degrees DeltaT. Now, and this is the point where the intelligent valve solutions kick in. They are able to measure the DeltaT and not only to limit the flow. And if we say for this coil, the real design DeltaT should be 6K, then we end up here. The intelligent valve now will measure this flow and return temperature, see that the DeltaT is violated, and decrease the flow even a little bit more than the traditional presetted PICV. It will take care about the 6K DeltaT, and with that, it will limit the flow to a certain level, assuming here round about 97, 98 cubic meters, and it will up in a slightly, really only slightly decrease on the power transmission of this coil, because on the one hand side we have decreased flow, but on the other hand we have increased DeltaT. So we still provide the right power to this coil to do its job, to transmit the right energy to the air handling unit. And this flow limitation we see here from, that is 103 to 90 cubic meters, this more than 10% flow limitation or less flow, this only results in 2 to 3% less power, as you see on the left-hand side. So DeltaT, we now with an intelligent valve solution, we can have in any and each operation situation under control. And even we have it dynamically under control. So if the coil starts, to get, to have a weaker performance due to some dirt and dust in the coil, or if the airflow on the secondary side is reduced to a lower level due to a new situation in the building, it will react on this. So also over lifetime, this will always be an optimization to DeltaT and an optimization to maximum chiller efficiency and lowest possible volume flow in the system in each and any solution. And doing this will allow us even to save a little bit more energy than just with a PICV solution. We assume a 1-digit saving in energy, as you see here, 5 to 7% of energy saving with such intelligent valve solutions compared to PICV, just PICV designed networks, 7% additional energy saving on this. And this 7% energy saving, there we have clearly two situations. We have local chiller installations with a local distribution. So the efficiency sums up in operational cost savings for the owner. And we have an additional effect if we are connected to networks, for instance, to district cooling networks, where usually the building owner or the operator has a contract with the utility and where he is forced to have only a certain power consumption for his building, and also more and more only to guarantee a certain return or return temperature or a certain DeltaT. So there, with a DeltaT capable solution, DeltaT control capable solution, we are able to have this DeltaT under control, and so also the contract to the utility under control, which avoids any unsatisfied relationships to him, or even it avoids penalties. Does it pay off? An intelligent valve solution. Let's assume the building Luca mentioned, 500 rooms with 500 PICVs and 20 valves in the distribution area, some valves for air handling units, some valves for distribution bars, for distributing to the fan coil solutions there. If we assume this and we have a traditional installation with PICVs for these 20 valves in the distribution, we would assume an investment of around about 9,000 euros. On the other hand side, if we do this with the intelligent valve solutions, we have to assume a higher investment cost, like shown here, around about 16,500 euros. So we have a higher investment cost of 7,000 euros, 7,500 euros. If you now imagine that this building with the 500 consumers has a yearly energy consumption of about 1,980 megawatt hours, with a typical cooling cold water energy costs of 100 euros per megawatt hour, this will sum up in 98,000 euros as energy cost for the cooling distribution. And then with a saving of 7%, the yearly savings will be around 7,000 euros. So such an intelligent valve solution with a perfect DeltaT control will finally pay off after 1 year roundabout. If you align these values in regards of energy cost and so on to your local situation, there might be something else. But finally, such a solution with the even only 1-digit energy saving on the generation for the cooled energy will pay off within 1 to 2 years from our point of view. Now I mentioned also this allows you, these intelligent solutions also allows you a proper energy reporting and supervising. There we have two solutions today with such intelligent valves. On the one hand side, without investments into a building management system and so on, today's are the capabilities to integrate the product into a cloud solution. For us, it's called a building operator. For others, it may be their own cloud solution. This allows not only to integrate usually the energy valves, but also it allows to operate with the other automation devices like the controllers and even sometimes also into access control, into fire control panels and so on, so that we have everything under control with this cloud solution. For intelligent solutions, the interesting thing on these cloud solutions is clearly you are online connected to these devices on the distribution level. With a dashboard, you can see what matters. You can see the current power consumption. You can clearly see alarms which are coming from this device. If a sensor is broken or if it's not capable to transmit the right power because somehow the distribution network does not provide the right temperature levels and so on. So there you have the capability for monitoring the system. And on the second level, you clearly get out of this energy reports and data. So you can do hourly breakdowns of the energy provided in the network. You have the dashboard, and you can export these energy reports out of this solution for your optimization, later optimization of the building. In addition, this also for sure allows that you interact with the devices. So if you have alarms, you can run test cycles on the device. Also, you can remotely change parameters on the device. So if there is a need to adapt to an, let's say, emergency solution, like a chiller is get damaged and non-operational, and you have to reduce the power distribution in the network, you can immediately reduce the power to certain razors, so that important razors gets still the power, say the full power they need, for instance, server rooms or something like that, or pharmaceutical laboratories get the right power, and less important risers to other areas get a limited power consumption only and will suffer a little bit in comfort. Nevertheless, this is a network device. These intelligent valves are network devices, so they can be integrated into the building management system and the building automation network as well by BACnet, by Modbus, on the level you need. We prefer BACnet IP because that's the most powerful and easiest from our point of view to commission together with the primary controllers. There you have the full transparency and the most performance out of this. And here you can do also similar things than with the cloud. You can do trendings, you can do energy reports, and here especially you can also do troubleshooting when there is something out of control. Or you can do override control for other special situations. Now, customers might say, okay, can't you do this also with the automation level controller if you have temperature sensors installed and so on? For sure you can, but think about the effort you have. You have to program this yourself, or your automation control provider has to program this by himself. There might be similar offerings. You might be in competition with similar offerings. You have also not only to have the DeltaT under control, but also you have to have this flow informations. Otherwise, you might even limit too far with the DeltaT control. So the intelligent valve solutions we see on the market, they are really a perfect package usually. They are pre-engineered, they integrate the flow sensor with the right resolution, with a wide measuring range. They have the right control valves pre-engineered here, and all the BACnet points into the network. They are pre-engineered, and you can easily integrate this with predefined function blocks into the automation level of the network. And also here we have, for the technicians, we have a really easy engineering software available. On the one hand side, an easy tool on mobile, in a mobile app for the presetting locally and for the troubleshooting locally. On the other hand, an engineering software if you integrate this into the automation level network with this predefined function blocks. And we are still working on energy optimization topics. We have the DeltaT control, but we are looking for automated functionalities to limit the flow control, to preset the flow. And also here we have the capability for automated balancing tests, and you can even do reports locally, so that you have you are assured that the presetting is done well and that the flow is available there. So overall, intelligent valve solutions are really a well-shaped package, and not only DeltaT control. Okay, so that was it from my side. Thank you for your attention, and I like to hand back. Okay, thank you.
Fantastic, excellent presentation. Thank you, Luca. Thank you, Jörg, for providing us such a good insight to PICVs as well as intelligent valve systems. So I would like to remind the audience, if you have any questions, please feel free to ask them through the questions chat box.
Jason, this is Ankit. As of now, I can see one question on the topic. So shall I take that one, or shall we wait for more questions?
Please go ahead, take that question while we wait for more questions.
Okay. All right, great. So this question is for Jörg. The question is how the intelligent valves can be used in retrofit buildings to enhance the energy saving and to avoid the DeltaT penalties.
Yes, as I mentioned, this is a well-shaped package. So currently, due to the request to a high resolution valve actuator combination, it is designed as a package with this valve actuator combination. If you have larger line sizes, you can perfectly also do this in a distributed installation. So you can keep the installation place for the control valve as it is and just replace the control valve, and you can put in the flow sensor. Let's say the control valve is in the return pipe, you can put in the flow sensor in the flow pipe. So there you are very flexible with the installation. And then you can integrate this analog. So if this is a 0 to 10 volt controller output controlling today the traditional control valve, these intelligent valve solutions are capable to work with analog control signals, so they must not be integrated into the BMS. If you do it with an analog control, it also works perfectly, and you can activate the DeltaT control locally. And if in future needed, then you can also think about an IP network to integrate this device into the cloud solution to avoid investments in regards of refurbishing the BMS system and integrating the valves into the BMS system. Just connect it via IP into the internet, and then you have also there with the cloud solution, energy reporting, remote presetting, and so on, and alarming available.
Great. Another question on the same is, can these valves integrated with any BMS provider, or it is only dedicated to Siemens BMS?
So it's a BTL certified BACnet device. Today it's BACnet IP, so you can integrate this by BACnet IP into any system, any brand which is capable to work with BACnet IP.
Yeah, I think BACnet IP is quite popular here, so I don't see a problem in connectivity with any other BMS company. Maybe it's Honeywell, Schneider, or Johnson as well. Right. Thank you, York. Another question. I'll take this question. It says, do we have any case study for this retrofit project in UAE? So for that question, I will contact Mr. Jayachandran, and then I will arrange some sort of information about the projects which we have done in UAE. So I'll take it up directly. So Mr. Jayachandran, I will contact you separately for this, and then we can take it forward on that.
Yeah, no issues, Ankit.
Thank you. And yeah, this was the last question I can see as of now.
All right, let's give it another minute just to allow anyone else to get in some last questions in case they have any.
And anyway, I will put my email ID and my phone number in the chat box for all the attendees. So if they have question at a later stage, feel free to contact me, and then I'll be happy to answer. And if needed, we can definitely arrange more information on the topic.
Ankit, I can also, what I can do from my side as well is I can just send out your email address to all the attendees, so they will get it along with the recording of the presentation.
Okay, would be perfect then.
Perfect. There's a question that came in. How can Luca had mentioned how to access the white paper from Siemens?
Yeah, I think this could also be followed up by you, Ankit, if you agree.
Yes. Yeah, for sure. I will share it with Grace. No problem.
Or as I mentioned, if you can share the link with me as well, I can send it out to all attendees.
No problem. I'll send it.
Perfect.
Exactly. No problem.
So just a question from my side, I would say. So we've seen PICVs, they already contribute to a significant amount of savings just using it as is. With the intelligent valve, you can push that savings up to additional about 7%, I believe, was the figure that Mr. York had presented. How would you convince I'm talking from a retrofit perspective here. How would you convince the landowner, the landlord, or the owner of the building to put in that extra cost? Because the payback's okay, it's about 13 months, but just making that argument, how would you do that?
You mean how do you calculate that? That's the question.
No. The question was, how would you convince your client basically to go the step beyond and look into the intelligent valve systems? Because PICV, as you mentioned, already has a saving. So why, what argument is there for the intelligent valve systems?
Yeah,
Want to answer?
Yeah. Beside, it's especially it's the financial aspects. These additional 7% basically pay off after, as I mentioned, one to 2 years. So then you will really have a less energy consuming and cost consuming building as today. As you mentioned, if you are in a retrofit situation, you are even working on it, correct? So you have already the interest to save energy. You have already the interest to increase comfort to your flat owners or habitants. So there you have already this interest, and to do this additional step in regards of investment, as I mentioned, after 1 to 1.5 years, that's not a lot in regards of payoff, and then you will save these 5 to 7,000 K year by year. So that maybe is the interest. The other point is, if you retrofit the building and you resize basically the building, you have to invest into smaller pumps. You have to think about what is with your chiller park in the building you have to invest in. Can I save their investment cost for this chiller park? These are all aspects, but they are in a short presentation complicated to show. That is more or less a case study than for such a kind of building where you have also the chiller park as a retrofit in the calculation and the complete distribution network. So that is, from my point of view, an additional lever, which we haven't shown here. This is just, should I go for a traditional PICV, mechanical PICV solution, or should I, at least on this distribution level, invest in this intelligent solutions with some capability for more savings and with the capability for more control across the building and faster troubleshooting as well, because then I know where the energy goes and where the temperatures are.
Great, fantastic answer. Thank you, Jörg. Ankit, we have 2 more questions that came in. Do you want to take those?
Yes, I will take one more question from there. So the next question is for Jörg. The question is, are there any chiller types that these valves are incompatible with? How, when we are on site, detect a good candidate for this retrofit?
So I'm not
So
aware.
my understanding of the question is, sorry. So my understanding of the question is that is there any specific type of the chiller to which these valves like PICV and the intelligent valves are compatible, or is there any restriction to the kind of chiller which is already there in the building where we cannot use the intelligent valves?
Yeah, from my point of view, you only have to take care about the variable flow. So here we have clearly, this is all based on a full variable flow throughout the network. So if the chiller has to be able to deal also with variable flows. If he is capable to do, then everything is fine. If he has limitation in regards of lowest flow or minimum flow, then it might be that you cannot really take everything out of this DeltaT control and out of the flow limitation, which the consumers allow. But if the chiller says, I need at least 80% of my maximum flow in operation, then it's another game, because then you have somehow to have a bypass, and the bypass will then destroy all your measures on the consumers to increase DeltaT, because the bypass then will clearly decrease DeltaT. So that's the only thing I have always in mind. Chiller have to be capable to deal with high variable flows.
Right. So it has to be, let's say it has to be looked into on project to project basis, and then yes, if we have some issues over there, that has to be rectified as well.
Yes, especially if we talk about retrofit, if we have in mind there might be a chiller park with this 15 years old, and these quite old chillers partially were not able to deal with variable flows.
Mm-hmm. All right, so I have another question here. This is Siemens is fully accredited ESCO in Dubai. Will it be offering this solution onto retrofit clients on guaranteed and shared saving EPC contract. So I would like to answer this question. Actually, we are from the product division side, and our ESCO division is a separate division, which actually does the overall solution for the ESCO. So I will direct this question to my colleagues Rohan and Uday at a later stage, and they can be in touch with James, and then we can see how we will offer the complete solution on this. Right, and I can see one more question. How efficient it will be for VFD chillers? Will it be same? Okay, so is there would be extra energy saving on the VFD chillers, or will it be same? Maybe Jörg, you can answer that.
Oh, I'm sorry, there we haven't looked into this specifically.
Okay, so
you might have to look in. So if you can forward me the question,
sure,
I can
I'll forward it.
work on this.
All right, so we'll come back to you, Mr. Jayachandran, on that. Yeah. Then I can see another question. Does the intelligent valve need to move if DP changes?
Yes, for sure. It's a dynamic balancing solution. So as long as the set point does not change, it will keep flow. The set point does not change, and the delta T is above limitation value. Then it will change position to maintain the flow during pressure fluctuations.
Okay, great. So this was the last question I had.
Perfect. Well, once again, thank you, Jörg, thank you, Ankit, thank you, Luca, and thank you, Mohammed, as well, and Siemens especially for facilitating this wonderful and extremely informative webinar. So thank you, everyone, for your questions. As mentioned, we will be following up with some of the questions you've asked, and we'll also be sharing access to the presentation, the white paper, as well as Mr. Ankit's email address. So thank you everyone for joining us, and have a good day. Bye-bye.
Thank you, everyone.
Thank you, everyone. Thank you for your time.
Thank you. Bye-bye.
Thanks.